Albert Einstein, one of history's most brilliant minds, was born on March 14, 1879, in Ulm, a small city in the Kingdom of Württemberg in the German Empire. He was the first child of Hermann and Pauline Einstein, a middle-class Jewish family. Although his birthplace was modest, the legacy he would leave behind was anything but ordinary. From the very beginning, Einstein's life showed glimpses of a curiosity that would later revolutionize science. As a young boy, Einstein displayed traits that set him apart from his peers. His mother often described him as a quiet child who spoke little. In fact, Einstein did not begin speaking in full sentences until he was around 4 years old, causing concern among his parents. However, this early silence belied an active and analytical mind. According to family anecdotes, young Albert would later surprise everyone by speaking fluently and articulating complex ideas. Einstein's early education in Munich, where his family moved shortly after his birth, was shaped by the German schooling system, which was rigid and disciplinarian. While he excelled in mathematics and physics, he struggled with the rote memorization and authoritarian teaching style of his teachers. Einstein often clashed with the structure of his school, which he found stifling to creativity and independent thought. This tension with traditional education would be a recurring theme in his life, shaping his perspectives on learning and innovation. Despite his dissatisfaction with formal schooling, Einstein demonstrated an insatiable curiosity about the world. A pivotal moment came when his father gifted him a compass at the age of 5. Fascinated by the needle's consistent alignment to the north, Einstein was captivated by the invisible forces at play. This seemingly ordinary object ignited his lifelong fascination with physics and the mysteries of the natural world. Family life played an essential role in Einstein's intellectual development. His mother, Pauline, was a talented pianist, and she introduced Albert to music at an early age. Although he initially resisted lessons, he eventually developed a deep love for playing the violin, which became a lifelong passion and a source of solace. His father, Hermann, was an engineer and entrepreneur who ran an electrochemical business. While his father's ventures often faced financial difficulties, they exposed young Albert to the practical applications of science and technology. Einstein's family also nurtured his academic interests by providing books and intellectual stimulation. His uncle Jacob, an engineer, frequently discussed mathematical problems with him, further encouraging his analytical thinking. These familial influences helped offset the rigid confines of his formal education and laid the foundation for his future brilliance. The Einsteins' financial struggles eventually forced the family to relocate to Italy in 1894, leaving Albert behind in Munich to complete his schooling. This separation was difficult for the young Einstein, who felt isolated and unhappy at his boarding school. His discontent reached a breaking point, and at the age of 15, he decided to leave school without completing his diploma. This decision marked a bold rejection of traditional pathways and demonstrated his determination to chart his own course in life. After leaving school, Einstein reunited with his family in Italy, where he began to cultivate his independent learning habits. He immersed himself in self-study, reading about philosophy, mathematics, and science. One of the works that profoundly influenced him was a treatise on electricity and magnetism by James Clerk Maxwell, which introduced him to the interplay of light, electricity, and magnetism. Although Einstein's unconventional path worried his parents, his academic potential was undeniable. In 1895, he applied to the Swiss Federal Polytechnic in Zurich, a prestigious institution known for its emphasis on science and engineering. Despite failing the entrance exam due to insufficient preparation in subjects outside of mathematics and physics, he was determined to succeed. He spent the following year studying at a secondary school in Aarau, Switzerland, where he thrived in a more progressive and supportive environment. Albert Einstein's early years were marked by challenges, curiosity, and an unyielding desire to understand the world around him. These formative experiences, his struggles with traditional education, the intellectual support of his family, and his exposure to transformative ideas, shaped the foundation of a man who would later change the course of human history. Albert Einstein's journey into adulthood was marked by transformative experiences that honed his intellect and solidified his aspirations in science. After leaving his native Germany, Einstein sought an education that would align with his insatiable curiosity and distaste for rigid academic systems. His time in Switzerland during the late 1890s and early 1900s became a crucial period of growth, independence, and intellectual discovery. Einstein's first step in this phase was enrolling in the Cantonal School in Aarau, Switzerland, in 1895. This institution was a stark contrast to the authoritarian schools of Germany. The Swiss education system emphasized critical thinking, creativity, and individual development, which resonated deeply with Einstein. His teachers encouraged exploration rather than rote memorization, and he thrived in this environment. He quickly excelled in mathematics and physics, subjects he had long been passionate about, while also cultivating an appreciation for philosophy and literature. One of the most influential figures in this period was Jost Winteler, Einstein's teacher in Aarau, who recognized his exceptional potential. Winteler's open-minded approach to education and his familial warmth provided Einstein with both intellectual stimulation and emotional support. The Winteler family became close to Einstein, and he even formed a romantic relationship with Winteler's daughter, Marie, although it was short-lived. These personal connections grounded Einstein during a time of transition and growth. In 1896, Einstein officially renounced his German citizenship, a bold and symbolic act that underscored his rejection of nationalism and authoritarianism. He became stateless, a condition that reflected both his philosophical outlook and his sense of personal freedom. Later that year, he was admitted to the Swiss Federal Polytechnic in Zurich, where he began his formal studies in physics and mathematics. The Polytechnic was a vibrant intellectual hub, attracting talented students and professors from across Europe. Einstein's time there was formative not only because of the knowledge he gained, but also because of the relationships he forged. Among his peers was Mileva Maric, a Serbian student who was the only woman in the physics program. Einstein and Maric shared a deep intellectual connection, and their friendship eventually blossomed into a romantic partnership. Maric would play a significant role in Einstein's life, both personally and professionally, though their relationship was complex and fraught with challenges. While Einstein excelled in theoretical understanding, his unconventional learning style occasionally put him at odds with his professors. He often skipped lectures he deemed unhelpful, preferring to study independently or discuss ideas with friends. This approach earned him a reputation as a rebellious student, and some professors, such as Heinrich Weber, viewed him unfavorably. However, Einstein found allies in other faculty members, including mathematician Marcel Grossmann, whose friendship would prove invaluable in his career. Despite his brilliance, Einstein faced significant hurdles upon graduating in 1900. His independent streak and strained relationships with certain professors made securing academic recommendations difficult. As a result, Einstein struggled to find a teaching position or research appointment. For nearly 2 years, he took on various temporary jobs while continuing his scientific pursuits on the side. This period of uncertainty was a humbling experience for Einstein, but it also reinforced his resilience and determination. In 1902, Einstein finally secured a position at the Swiss Patent Office in Bern. This seemingly mundane job as a technical examiner provided him with financial stability and ample free time to develop his scientific ideas. Reviewing patent applications for inventions required analytical thinking, and the work indirectly fueled his creativity. Einstein often referred to his time at the Patent Office as a period of intellectual freedom, allowing him to explore groundbreaking theories without the constraints of academic bureaucracy. During this period, Einstein formed the Olympia Academy, an informal group of like-minded friends who met regularly to discuss philosophy, science, and literature. These discussions, often held late into the night, were intellectually stimulating and helped shape Einstein's thinking. Members of the group, including Maurice Solovine and Conrad Habich, challenged and supported Einstein's ideas, fostering an environment of collaborative learning. The formative years of Albert Einstein's life were defined by his pursuit of knowledge and his ability to overcome adversity. From the progressive environment of Aarau to the intellectual rigor of the Polytechnic, Einstein laid the groundwork for his future discoveries. These experiences shaped him not only as a scientist, but also as a thinker who valued independence, creativity, and collaboration. By the early 1900s, Einstein was poised to embark on a journey that would redefine the boundaries of physics and alter humanity's understanding of the universe. The year 1905 stands as one of the most remarkable periods in the history of science, often referred to as Albert Einstein's Annus Mirabilis or Miracle Year. In this singular year, Einstein, then a relatively unknown physicist working at the Swiss Patent Office in Bern, published 4 groundbreaking papers that fundamentally transformed our understanding of the physical world. These works, addressing the photoelectric effect, Brownian motion, special relativity, and the equivalence of mass and energy, established Einstein as a towering figure in theoretical physics. The first of these papers, published in March 1905, dealt with the photoelectric effect. In this work, Einstein proposed that light could be understood as consisting of discrete packets of energy, later called photons. This idea, building on Max Planck's quantum hypothesis, challenged the classical wave theory of light. Einstein demonstrated that the energy of these photons was proportional to their frequency and used this insight to explain how light could eject electrons from a metal surface. This paper not only provided the first clear evidence for the quantum nature of light, but also laid the foundation for quantum mechanics, a field that would dominate 20th century physics. Einstein's second paper, published in May 1905, focused on Brownian motion. This phenomenon, first observed by botanist Robert Brown in 1827, described the erratic motion of particles suspended in a fluid. Einstein's work provided a theoretical explanation for this behavior by using statistical mechanics and the molecular theory of matter. He demonstrated that the random motion of particles could be attributed to collisions with the molecules of the surrounding fluid. This paper provided direct evidence for the existence of atoms and molecules, lending support to the atomic theory, which was still debated at the time. In June 1905, Einstein published his third and arguably most famous paper, introducing the theory of special relativity. This revolutionary work addressed the inconsistencies between classical mechanics and electromagnetism, particularly as described by James Clerk Maxwell's equations. Einstein discarded the notion of an absolute space and time, proposing instead that the laws of physics are the same for all observers in uniform motion. His theory showed that measurements of time and space are relative and depend on the observer's frame of reference. This radical departure from Newtonian mechanics redefined fundamental concepts of motion, causality, and simultaneity. The culmination of Einstein's special relativity work came in his fourth paper, published in September 1905. This equation expressed the equivalence of mass and energy, suggesting that a small amount of mass could be converted into an enormous amount of energy. While the practical implications of this insight were not immediately realized, it would later become the theoretical basis for the development of nuclear energy and weapons. Einstein's ability to produce such groundbreaking work in a single year was not only a testament to his genius, but also to his unique approach to problem solving. Unlike many of his contemporaries, Einstein was not bound by experimental data or established paradigms. Instead, he relied on thought experiments, imaginative reasoning, and a deep curiosity about the fundamental principles of nature. His capacity to think abstractly allowed him to challenge conventional wisdom and uncover profound truths about the universe. Despite the monumental significance of these papers, Einstein's achievements were not immediately recognized. The academic community was slow to appreciate the full implications of his work, partly because he was not affiliated with a major university and lacked formal recognition. However, as scientists began to verify his predictions and explore the implications of his theories, Einstein's reputation grew rapidly. Within a decade, he would be hailed as one of the leading minds of his time. The Annus Mirabilis papers also marked a turning point in the broader field of physics. Einstein's contributions challenged the classical worldview that had dominated since Newton and ushered in a new era of modern physics. His work on the photoelectric effect provided the foundation for quantum theory, while his theory of relativity redefined our understanding of space, time, and energy. These dual revolutions would shape the trajectory of scientific inquiry for generations to come. Einstein's achievements in 1905 were made all the more remarkable by the circumstances of his life at the time. As a young patent clerk, he lacked access to the resources of a university or research institution. Nevertheless, his independence from academic orthodoxy may have been an advantage, allowing him to think freely and pursue unconventional ideas. His determination and creativity exemplify the power of intellectual curiosity and perseverance. The miracle year of 1905 established Albert Einstein as a central figure in the scientific revolution of the 20th century. Each of his 4 papers could have secured his place in history on its own, but together, they represent an unparalleled intellectual achievement. This remarkable period not only transformed Einstein's life, but also reshaped humanity's understanding of the universe, setting the stage for a century of discovery and innovation. After his Annus Mirabilis in 1905, Albert Einstein's contributions to science did not cease. Rather, they evolved and deepened, culminating in the development of the general theory of relativity. This groundbreaking work, published in 1915, extended the principles of special relativity to include gravity, redefining humanity's understanding of one of the fundamental forces of nature. In doing so, Einstein not only solved long-standing problems in classical mechanics, but also opened new frontiers in astrophysics and cosmology. The general theory of relativity arose from Einstein's dissatisfaction with the Newtonian conception of gravity. According to Isaac Newton, gravity was an invisible force that acted instantaneously across distances, pulling objects toward one another. While this explanation sufficed for many practical purposes, it was fundamentally at odds with the principles of special relativity, which stated that nothing, not even information, could travel faster than the speed of light. Einstein sought to resolve this inconsistency by developing a new theory of gravity that adhered to the relativistic framework. Einstein's key insight was that gravity was not a force in the traditional sense, but rather a manifestation of the curvature of space-time. Massive objects, such as planets and stars, distort the fabric of space-time, creating a dimpled effect. Smaller objects, like moons or satellites, move along these curves, giving the appearance of being pulled by an invisible force. This revolutionary idea transformed the way scientists understood gravitational interactions, replacing Newton's static framework with a dynamic and geometric perspective. The formulation of general relativity was not a straightforward process. It took Einstein nearly a decade of intense work, collaboration, and refinement to develop the mathematical framework necessary to describe the curvature of spacetime. A crucial breakthrough came with his adoption of the field equations, a set of 10 interrelated differential equations that describe how matter and energy influence spacetime geometry. These equations became the cornerstone of general relativity and remain one of the most elegant mathematical formulations in physics. Einstein's theory made bold predictions that could be tested through observation. One such prediction was the bending of light by gravity, a phenomenon known as gravitational lensing. According to general relativity, light traveling near a massive object, such as the sun, would follow the curvature of spacetime, causing it to appear displaced from its original path. This idea challenged the classical assumption that light always traveled in straight lines. In 1919, Einstein's theory was famously validated during a solar eclipse. British astronomer Sir Arthur Eddington organized an expedition to observe the positions of stars near the sun's edge during the eclipse. The observed deflection of starlight matched Einstein's predictions, providing dramatic confirmation of general relativity. The results catapulted Einstein to international fame, solidifying his status as a scientific visionary and a household name. Beyond its implications for gravitational phenomena, general relativity transformed the study of the universe as a whole. It provided the theoretical foundation for modern cosmology, offering insights into the origins, structure, and ultimate fate of the cosmos. Einstein's equations predicted the possibility of an expanding or contracting universe, a concept that was initially unsettling to him. He famously introduced the cosmological constant, a term designed to maintain a static universe, but later referred to it as his greatest blunder when evidence of cosmic expansion was discovered by Edwin Hubble. General relativity also paved the way for exploring extreme environments, such as black holes and neutron stars. The theory predicted the existence of singularities, regions of space-time where gravitational forces become infinitely strong. Although Einstein himself was initially skeptical of the physical reality of black holes, later developments in astrophysics confirmed their existence, further vindicating his work. The impact of general relativity extended far beyond the scientific community. It captured the public imagination, not only for its profound implications, but also for the sheer beauty and elegance of its ideas. Einstein became a symbol of intellectual achievement, embodying the power of human curiosity and ingenuity. His ability to envision the universe in ways no one had before inspired a new generation of physicists and thinkers. Einstein's revolution in physics was not without challenges. The abstract nature of his ideas and the complex mathematics involved made general relativity difficult to grasp for many of his contemporaries. Nevertheless, the theory endured, thanks to its predictive power and its ability to explain phenomena that classical mechanics could not. More than a century later, general relativity remains a cornerstone of modern physics, underpinning technologies like GPS and guiding research into the mysteries of the universe. Einstein's development of general relativity marked a turning point in the history of science. It demonstrated the power of creative thinking and the capacity of the human mind to uncover truths about the cosmos. By daring to question long-standing assumptions and reimagining the nature of gravity, Einstein not only revolutionized physics, but also redefined humanity's place in the vast and intricate tapestry of the universe. Following the publication and eventual validation of his general theory of relativity, Albert Einstein's reputation as one of the most influential scientists in history was firmly established. His rise to prominence within the academic world was swift and remarkable, as his groundbreaking ideas reshaped physics and earned him international acclaim. Over the next 2 decades, Einstein's professional career flourished, and he became a central figure in both scientific and public spheres. Einstein's academic ascendancy began in earnest in 1909 when he was appointed as an associate professor at the University of Zurich, marking his transition from the Swiss Patent Office to academia. His contributions to theoretical physics during his time at the Polytechnic and beyond had already garnered attention, and this appointment allowed him to focus entirely on his research. Within 2 years, he moved to the German University in Prague, where he served as a full professor. These early positions helped solidify his standing within the academic community, even as his ideas were still met with skepticism by some. In 1914, Einstein accepted a prestigious appointment at the Prussian Academy of Sciences in Berlin, coupled with a professorship at the University of Berlin. This position came with few teaching responsibilities, allowing Einstein the freedom to focus on his research. It was during his tenure in Berlin that he completed his work on general relativity, a feat that not only solidified his reputation, but also redefined the scientific community's understanding of gravity and space-time. Einstein's academic achievements earned him numerous accolades, including the Nobel Prize in Physics in 1921. Interestingly, the award was not granted for his theory of relativity, as it remained controversial at the time, but for his explanation of the photoelectric effect, which had laid the foundation for quantum mechanics. This recognition affirmed Einstein's profound impact on physics and underscored the broad scope of his contributions to the field. Throughout the 1920s, Einstein became an increasingly prominent figure in international scientific and intellectual circles. He was frequently invited to lecture at universities and conferences worldwide, sharing his insights on physics and philosophy. His lectures not only disseminated his ideas, but also inspired a generation of young scientists to explore the frontiers of modern physics. Einstein's ability to communicate complex concepts in an accessible manner further enhanced his reputation as both a thinker and a teacher. Einstein's professional success, however, was not without its challenges. His growing fame attracted scrutiny and criticism, particularly from those who viewed his theories as too radical or abstract. Some physicists, including proponents of more traditional approaches, resisted his ideas, and the reception of his work varied across the scientific community. Nevertheless, Einstein remained undeterred, confident in the validity of his theories and the predictive power of his equations. Einstein's role as a leading academic figure also extended into scientific organizations and collaborative efforts. He was a founding member of the Hebrew University of Jerusalem, established in 1925, and contributed to its development as a center for higher education and research. He also participated in international organizations such as the League of Nations Committee on Intellectual Cooperation, advocating for the importance of science and culture in fostering global understanding. The recognition Einstein received was not confined to the scientific community. His achievements made him a cultural icon, celebrated as a symbol of intellectual brilliance. His distinctive appearance, with his wild hair and unassuming demeanor, became instantly recognizable, further contributing to his celebrity status. Einstein's fame, however, was a double-edged sword. While it brought him widespread admiration, it also subjected him to intense public scrutiny and the pressures of living up to his legendary image. Despite the demands of his professional and public life, Einstein maintained a strong commitment to scientific inquiry. He continued to explore fundamental questions in physics, including efforts to unify the forces of nature under a single theoretical framework. Although he did not succeed in developing a unified field theory, his work in this area reflected his unyielding dedication to understanding the universe's deepest mysteries. Einstein's academic and professional rise was unparalleled, transforming him into one of the most influential figures of the 20th century. His contributions to science not only reshaped the field of physics, but also inspired a new era of exploration and discovery. As his career progressed, Einstein's influence extended beyond the realm of academia, positioning him as a global symbol of intellectual achievement and the transformative power of human curiosity. As Albert Einstein's fame grew, so did his role as a public intellectual and advocate for social and political causes. His scientific achievements had made him a household name, but his humanity and unwavering principles solidified his place as a moral leader in an increasingly turbulent world. From the 1920s onward, Einstein used his platform to champion peace, civil rights, and global cooperation, becoming a symbol of ethical responsibility in the face of global challenges. Einstein's advocacy for peace was deeply rooted in his personal experiences and philosophical convictions. Having witnessed the devastation of World War I, he became an outspoken critic of militarism and nationalism. He saw these forces as antithetical to the progress of humanity and believed that science and education could serve as tools to promote understanding and cooperation among nations. Einstein joined the pacifist movement and frequently spoke out against the arms race, emphasizing the dangers it posed to global stability. His commitment to pacifism, however, was tested as the world moved toward World War II. The rise of Adolf Hitler and the Nazi regime in Germany deeply affected Einstein, both personally and professionally. As a Jew, Einstein became a target of Nazi propaganda, and his scientific work was denounced as Jewish physics. In 1933, Einstein made the difficult decision to leave Germany permanently, settling in the United States where he accepted a position at the Institute for Advanced Study in Princeton, New Jersey. The horrors of the Holocaust and the aggressive expansion of fascist ideologies forced Einstein to reevaluate his stance on pacifism. Though he remained committed to the ideal of peace, he recognized the necessity of opposing tyranny through force when no other options remained. This shift in perspective was most evident in his involvement with the development of nuclear weapons, a decision that would haunt him for the rest of his life. In 1939, Einstein co-signed a letter to President Franklin D. Roosevelt, warning that Germany might be attempting to develop an atomic bomb and urging the United States to accelerate its own nuclear research. This letter, written with physicist Leo Szilard, played a key role in initiating the Manhattan Project. While Einstein did not directly work on the project, his letter underscored the ethical dilemmas faced by scientists in wartime, as their knowledge could be used for both constructive and destructive purposes. The atomic bombings of Hiroshima and Nagasaki in 1945 deeply troubled Einstein. He expressed profound regret over his role in the chain of events that led to the weapon's creation, famously stating, "If I had known that the Germans would not succeed in producing an atomic bomb, I would have never lifted a finger. After the war, Einstein became a vocal advocate for nuclear disarmament, warning of the catastrophic consequences of a nuclear arms race. He joined efforts to promote international control of nuclear technology and urged world leaders to prioritize diplomacy over conflict. Einstein's advocacy extended beyond the issue of war and peace. He was an ardent supporter of civil rights and social justice, particularly in his adopted home of the United States. He spoke out against racism and segregation, describing it as a disease of white people and calling for equal rights for all. Einstein developed a close friendship with African-American scholar and activist W.E.B. Du Bois and publicly supported the civil rights movement, lending his voice to campaigns for racial equality. Einstein also played an active role in the Zionist movement, supporting the establishment of a Jewish homeland in Palestine as a refuge for persecuted Jews. However, his vision for Zionism was one of coexistence and mutual respect between Jews and Arabs, rather than political dominance. In 1952, Einstein was offered the presidency of Israel, a ceremonial role, but he declined, citing his lack of political experience and his desire to focus on science and global peace initiatives. Despite his immense fame, Einstein remained deeply humble and committed to the principles of simplicity and kindness. He often used his public appearances and writings to emphasize the importance of compassion, intellectual curiosity, and ethical responsibility. He viewed science as a means to improve the human condition, not just as a pursuit of knowledge for its own sake. His willingness to engage with pressing social issues reflected his belief that scientists had a duty to contribute to the betterment of society. Albert Einstein's legacy as a voice for peace and humanity transcends his scientific accomplishments. While his theories revolutionized physics, his moral courage and advocacy for justice inspired countless individuals to pursue a better, more equitable world. Einstein's ability to navigate the complex interplay between science and society remains a testament to the enduring power of intellect and conscience in shaping the course of history. His life serves as a reminder that true greatness lies not only in the pursuit of knowledge, but also in the wisdom to use that knowledge for the benefit of all. Albert Einstein's contributions to science and society left an indelible mark on human history, a legacy that continues to influence fields ranging from theoretical physics to philosophy and beyond. His revolutionary ideas redefined humanity's understanding of the universe, while his moral and ethical principles provided a framework for addressing the challenges of a rapidly changing world. As both a scientist and a public intellectual, Einstein's enduring impact can be seen in his scientific theories, his philosophical insights, and his role as a symbol of intellectual curiosity and humanitarianism. Einstein's most profound scientific contributions are embodied in the theories of special and general relativity. These groundbreaking ideas challenge classical conceptions of space, time, and gravity, offering a new framework for understanding the fundamental nature of the universe. The implications of these theories were immense, influencing everything from astrophysics to modern technology. For example, the concept of time dilation, a prediction of special relativity, is essential for the precise functioning of GPS systems, which rely on accurate timekeeping in orbiting satellites. Similarly, general relativity has become the cornerstone of cosmology, underpinning studies of black holes, gravitational waves, and the expanding universe. The discovery of gravitational waves in 2015, a century after Einstein predicted their existence, stands as a testament to the enduring power of his theories. This landmark achievement, made possible by advanced detection methods and international collaboration, confirmed yet another aspect of general relativity and opened new avenues for exploring the cosmos. Einstein's work laid the foundation for such discoveries, demonstrating the depth and foresight of his scientific vision. Beyond his technical contributions, Einstein's ideas also shaped the philosophical foundations of science. He was a vocal advocate for the importance of theoretical thinking, emphasizing the role of imagination and creativity in scientific discovery. His thought experiments, such as envisioning himself riding a beam of light, exemplified his unique approach to problem-solving. This emphasis on abstract reasoning inspired generations of physicists to explore the frontiers of knowledge and remains a guiding principle in the pursuit of scientific breakthroughs. Einstein's influence extended into the realm of quantum mechanics. Even though he famously struggled to reconcile its principles with his own understanding of the universe. His work on the photoelectric effect laid the groundwork for quantum theory, a field that would later revolutionize technology through innovations like semiconductors, lasers, and quantum computing. However, Einstein's discomfort with the probabilistic nature of quantum mechanics, encapsulated in his remark, "God does not play dice with the universe," highlighted his philosophical commitment to determinism and a search for a deeper, underlying order in nature. In addition to his scientific achievements, Einstein's legacy as a public intellectual is equally significant. He viewed science as a tool for improving the human condition and believed that scientists had a moral responsibility to address societal issues. His advocacy for peace, civil rights, and global cooperation set a precedent for scientists engaging with ethical and political challenges. Einstein's open letters, public speeches, and involvement in humanitarian causes demonstrated his commitment to using his influence for the greater good. Einstein's status as a cultural icon further cemented his legacy. His image, characterized by his wild hair, piercing eyes, and kind demeanor, became synonymous with genius and intellectual independence. While this fame brought its own challenges, Einstein used his platform to promote education, critical thinking, and empathy. His writings and interviews often reflected his humility and his belief in the power of individual creativity and perseverance. The establishment of the Albert Einstein Archives, housing thousands of his letters, manuscripts, and photographs, ensures that his legacy will continue to inspire future generations. These documents provide invaluable insights into Einstein's thought processes, personal struggles, and philosophical reflections. They reveal a man deeply concerned with the welfare of humanity, as well as a relentless seeker of truth in both the scientific and moral realms. Einstein's impact on education and scientific collaboration cannot be overstated. Institutions such as the Institute for Advanced Study, where Einstein worked during his later years, continue to foster interdisciplinary research and intellectual exchange. His commitment to fostering curiosity and inquiry is evident in the countless schools, universities, and research centers that bear his name, serving as a reminder of the transformative power of knowledge. Albert Einstein's legacy is not confined to his scientific achievements, but extends into the broader tapestry of human culture and progress. His life and work exemplify the interplay between intellect and ethics, reminding humanity of its potential to unlock the mysteries of the universe while striving for a more just and peaceful world. Einstein's story continues to resonate as a beacon of inspiration, illustrating that the pursuit of knowledge is inseparable from the responsibility to use it wisely and compassionately. Albert Einstein's later years were marked by a blend of intellectual pursuits, philosophical musings, and active engagement with the world's pressing issues. While he had already established himself as one of the greatest minds in history, Einstein spent the final decades of his life grappling with unresolved scientific questions and reflecting on the ethical dimensions of science and humanity's future. These years offer a poignant portrait of a thinker whose curiosity and moral convictions remained undiminished even as his influence and fame grew. In 1933, Einstein had permanently relocated to the United States to escape the rise of the Nazi regime in Germany. Settling in Princeton, New Jersey, he accepted a position at the Institute for Advanced Study, where he spent the remainder of his career. This institution, known for its emphasis on theoretical research, provided Einstein with the intellectual freedom he cherished. While he no longer needed to teach or publish as prolifically, he continued to engage deeply with scientific inquiry, particularly his quest for a unified field theory. The idea of a unified field theory preoccupied Einstein during his later years. This ambitious project sought to combine the forces of gravity and electromagnetism into a single theoretical framework. Einstein believed that such a theory would reveal the underlying harmony of the universe, aligning with his lifelong search for order and simplicity in nature. However, his efforts were met with significant challenges. The emergence of quantum mechanics, with its probabilistic nature and focus on subatomic particles, presented a conceptual roadblock to Einstein's deterministic worldview. Despite his relentless work, Einstein never succeeded in formulating a complete unified theory, a task that remains one of the great challenges in physics today. Einstein's later years also saw him grappling with the implications of his earlier work on relativity and quantum theory. While he had contributed to the foundation of quantum mechanics through his explanation of the photoelectric effect and other insights, he remained deeply skeptical of its core principles, particularly its reliance on probabilities. Einstein's debates with Niels Bohr, a leading figure in quantum mechanics, became legendary in scientific circles. These debates centered on whether the universe was fundamentally deterministic or governed by randomness. Einstein famously declared, "God does not play dice," encapsulating his belief in an ordered universe, even as experimental evidence increasingly supported the probabilistic nature of quantum mechanics. Beyond his scientific endeavors, Einstein's later years were characterized by his philosophical reflections on humanity and its future. He became a vocal advocate for global peace, frequently warning of the dangers posed by nationalism, militarism, and nuclear weapons. The devastation wrought by World War II and the advent of the atomic age weighed heavily on him. Einstein often expressed regret for his indirect role in the development of nuclear weapons, particularly through his 1939 letter to President Roosevelt that had warned of Nazi Germany's potential nuclear ambitions. Einstein's advocacy for peace was not limited to rhetoric. He actively supported organizations that promoted international cooperation, disarmament, and human rights. He became a prominent member of the Emergency Committee of Atomic Scientists, a group dedicated to raising awareness of the dangers of nuclear weapons and advocating for their abolition. In his writings and public speeches, Einstein consistently called for the establishment of a world government that could prevent war and ensure the survival of humanity. Despite his fame, Einstein lived a simple and humble life during his later years. He often shunned the spotlight, preferring solitude and quiet contemplation. He enjoyed playing the violin, taking long walks, and engaging in conversations with close friends and colleagues. His personal correspondence from this period reveals a man deeply aware of his mortality, yet steadfast in his commitment to intellectual and ethical pursuits. Einstein's personal philosophy, rooted in a sense of wonder and humility, continued to evolve during his later years. He often described himself as a deeply religious non-believer, viewing the universe as an awe-inspiring mystery governed by natural laws. He rejected dogmatic religion, yet he embraced a cosmic spirituality that emphasized the interconnectedness of all things. This perspective influenced his ethical beliefs, including his emphasis on compassion, social justice, and the responsibility of individuals to contribute to the greater good. As he aged, Einstein became increasingly aware of his place in history. While he remained modest about his accomplishments, he understood the profound impact of his work on science and society. He maintained a lifelong commitment to education, often emphasizing the importance of critical thinking, curiosity, and creativity in shaping the next generation of scientists and thinkers. Albert Einstein passed away on April 18, 1955, at the age of 76, leaving behind a legacy that transcends time. His later years, characterized by intellectual rigor and moral clarity, serve as a testament to the enduring power of curiosity and conscience. Even as he faced the inevitable challenges of aging, Einstein remained true to his principles, continuing to inspire humanity with his unwavering pursuit of knowledge and his vision for a better world. His final years were not merely a conclusion to an extraordinary life, but a reflection of the timeless values that defined him: a profound respect for truth, an abiding love for humanity, and an unrelenting desire to unlock the mysteries of existence. The legacy of Albert Einstein continues to reverberate through the halls of modern science and technology, as his groundbreaking theories and ideas have shaped contemporary research in physics, engineering, and beyond. Einstein's work fundamentally altered the trajectory of scientific inquiry in the 20th century, and his intellectual contributions remain a cornerstone of the scientific community. The profound impact of his theories, particularly those on relativity and quantum mechanics, is still felt today as scientists explore the furthest reaches of space, and the smallest particles of matter. One of the most enduring aspects of Einstein's legacy is his theory of relativity, which not only transformed the field of physics, but also laid the groundwork for many technological advances. The development of GPS technology is one of the most tangible applications of Einstein's general theory of relativity. Because the system's satellites orbit the Earth at high velocities, they experience time differently from objects on the Earth's surface due to time dilation, a phenomenon predicted by Einstein's equations. Without accounting for this relativistic effect, GPS systems would be inaccurate by miles. This real-world application of Einstein's theory is a testament to the far-reaching consequences of his work, highlighting how abstract scientific concepts can be applied to everyday life. In the realm of astrophysics, Einstein's general theory of relativity revolutionized the study of gravity and the cosmos. The theory provided the mathematical framework for understanding the curvature of space-time and the behavior of celestial bodies. It was instrumental in explaining phenomena such as the bending of light around massive objects, gravitational lensing, and the existence of black holes. The detection of gravitational waves in 2015, a century after Einstein first predicted them, was another monumental achievement in astrophysics that owed its foundation to his theory. This discovery not only confirmed Einstein's vision of the universe, but also opened new avenues for exploring the cosmos through gravitational wave astronomy. Einstein's theories also have significant implications for our understanding of the universe's origins. His equations played a pivotal role in the development of the Big Bang theory, which posits that the universe began as a singularity and has been expanding ever since. This theory, which is central to modern cosmology, finds its roots in Einstein's work on general relativity and his later contributions to the study of the universe's large-scale structure. Today, scientists use advanced telescopes and observatories to peer into the farthest reaches of space, studying the cosmic microwave background radiation left over from the Big Bang, further solidifying Einstein's contributions to the field. Einstein's contributions also paved the way for the advancement of quantum mechanics, although he himself had reservations about its principles. Quantum mechanics, which describes the behavior of particles on the atomic and subatomic scales, has become the foundation of modern physics and is responsible for many revolutionary technologies. Einstein's work on the photoelectric effect, for which he won the Nobel Prize in Physics in 1921, demonstrated the particle nature of light and helped to establish quantum theory. His insights into the interaction between light and matter were critical in the development of technologies such as lasers, semiconductors, and photovoltaic cells, all of which have become ubiquitous in modern life. The advent of quantum computing, an emerging technology based on the principles of quantum mechanics, can also trace its roots back to Einstein's early work. Quantum computers have the potential to revolutionize fields such as cryptography, artificial intelligence, and materials science by performing computations at speeds far beyond the capability of classical computers. While Einstein was skeptical of some aspects of quantum mechanics, his foundational contributions to the field are a key reason for the current surge of interest in quantum computing and related technologies. Einstein's legacy extends beyond the scientific community and has profoundly influenced the development of modern technology. His work on energy, mass, and the equivalence of energy and matter, encapsulated in the famous equation E=mc², has had a profound impact on the development of nuclear energy. While the use of nuclear technology for warfare remains controversial, Einstein's equation has been instrumental in the development of nuclear power as a source of energy, providing a significant, if contentious, contribution to the world's energy landscape. Einstein's intellectual influence also extends to the social sciences and philosophy. His ideas on the interconnectedness of science, philosophy, and ethics have inspired thinkers across disciplines. His reflections on the relationship between science and religion, for example, have sparked ongoing debates in philosophy of science, with his assertion that scientific inquiry and religious belief can coexist in a framework of awe and wonder. Furthermore, Einstein's advocacy for social justice, peace, and human rights has provided a model for scientists and intellectuals who seek to use their work for the greater good of society. In the field of education, Einstein's approach to learning and his emphasis on curiosity, imagination, and critical thinking have shaped modern pedagogy. His belief that education should foster creativity and independent thinking rather than rote memorization has influenced educational systems worldwide. Einstein's pedagogical philosophy encourages students to ask questions, challenge assumptions, and engage with the world in a thoughtful and inquisitive manner. As a result, his influence continues to be felt in classrooms and research institutions around the world. Einstein's lasting influence on modern science and technology is undeniable. His work has opened new frontiers of knowledge, from the study of black holes to the potential of quantum computing, and has led to technological advancements that have transformed the way we live. More than just a brilliant physicist, Einstein's contributions have shaped the very tools, technologies, and frameworks that define the modern world. His legacy endures as both a testament to the power of human curiosity and as a reminder of the profound responsibility that comes with scientific discovery. Today, Einstein remains an enduring symbol of the limitless possibilities of human intellect, and his impact continues to inspire and inform the pursuit of knowledge across disciplines. The legacy of Albert Einstein, both as a scientist and a humanitarian, transcends the boundaries of his time, leaving an indelible imprint on nearly every aspect of modern thought and society. More than a pioneering physicist whose theories reshaped our understanding of the universe, Einstein was a public intellectual whose ideas on ethics, philosophy, and social responsibility continue to resonate with global audiences. As both a scientific icon and a moral beacon, his legacy endures as a powerful symbol of intellectual curiosity, compassion, and the quest for truth. Einstein's scientific legacy is perhaps best embodied in his theories of relativity, which have redefined the very fabric of our understanding of space, time, and gravity. The continuing influence of general and special relativity is felt in fields as diverse as astrophysics, cosmology, and even engineering. From the accurate calibration of GPS satellites to the detection of gravitational waves, Einstein's work remains integral to technological advancements that have changed the way we interact with the world. As the universe continues to reveal its mysteries, Einstein's theories serve as the cornerstone of modern physics, with his ideas providing the framework for future discoveries. However, Einstein's contributions went far beyond theoretical physics. His involvement in the development of quantum mechanics, despite his reservations about the probabilistic nature of the theory, helped lay the foundation for technologies that shape everyday life. Lasers, semiconductors, and the emerging field of quantum computing all owe their existence, in part, to Einstein's groundbreaking work in the early 20th century. Through his explanation of the photoelectric effect, Einstein not only advanced our understanding of light, but also catalyzed innovations that have transformed industries and revolutionized communications, entertainment, and medicine. Einstein's influence also permeates the social and political spheres, where his voice served as a clarion call for peace, justice, and human dignity. Throughout his life, Einstein was an outspoken advocate for civil rights, especially in the United States, where he used his prominence to champion racial equality and speak out against segregation. His friendship with African-American figures such as W.E.B. Du Bois and his public condemnations of racism in all its forms solidified his reputation as an ally in the fight for social justice. Einstein's advocacy for peace, however, took on even greater significance as the world grappled with the rise of fascism, the horrors of World War II, and the advent of nuclear weapons. Einstein's role in the development of nuclear weapons, though indirect, remains one of the more complex aspects of his legacy. He famously signed a letter to President Franklin D. Roosevelt in 1939 that warned of the potential for Nazi Germany to develop an atomic bomb. While Einstein did not directly contribute to the Manhattan Project, his warning helped catalyze the U.S. government's nuclear research efforts. However, in the aftermath of the war, Einstein expressed profound regret for his role in the creation of the atomic bomb, becoming a staunch advocate for nuclear disarmament. His advocacy for global peace and his warnings about the perils of the arms race have taken on even greater relevance in the contemporary world, where the threat of nuclear conflict continues to loom. Beyond the physical realm, Einstein's philosophical reflections on science and religion have made a lasting impact. He famously described himself as a religious non-believer, a man who found a sense of awe and wonder in the natural world rather than in any traditional religious doctrine. His belief in a cosmic religion that celebrated the mystery and beauty of the universe resonated with thinkers across disciplines and continues to inspire a generation of scientists, philosophers, and writers. Einstein's views on the interconnectedness of science, ethics, and the search for truth remind us that intellectual inquiry is not only a pursuit of knowledge, but also a responsibility to humanity. Equally significant is Einstein's belief in the power of education and critical thinking. His insistence that students be encouraged to think for themselves, to question authority, and to challenge assumptions has influenced modern pedagogy in profound ways. Einstein was deeply concerned about the mechanization of education and the stifling of creativity, and he frequently argued that the purpose of education was not simply to impart knowledge, but to cultivate the capacity for independent thought. Today, his educational philosophy continues to inform progressive teaching methods, particularly in STEM fields, where creative problem-solving and curiosity-driven learning are highly valued. Moreover, Einstein's commitment to humanism and social responsibility extended to his active engagement with global causes, from the advocacy of Jewish refugees during World War II to his support for the establishment of the State of Israel. Though he was critical of certain aspects of Zionism and its political implications, he saw the establishment of Israel as an essential refuge for persecuted Jews and a necessary response to the horrors of the Holocaust. His vision for Israel, however, was one of peace and coexistence, and he advocated for the fair treatment of Arab populations and the peaceful resolution of the Israeli-Palestinian conflict, making his stance on the issue complex and nuanced. The physical and moral dimensions of Einstein's legacy converge in his enduring influence on the scientific community. His insistence on intellectual rigor, his commitment to the pursuit of truth, and his willingness to challenge accepted paradigms set a standard for generations of scientists to follow. His contributions to theoretical physics continue to inspire ongoing research into the fundamental forces of nature, and his insistence on the moral responsibility of scientists remains a guiding principle for those who use their knowledge to shape the future. Einstein's life stands as a testament to the power of individual curiosity, ethical commitment, and the relentless pursuit of understanding. As we look to the future, Einstein's influence remains not only a cornerstone of scientific knowledge, but also a beacon for how humanity might approach the profound challenges that lie ahead. In an era marked by climate change, political polarization, and the rapid advancement of technology, Einstein's advocacy for peace, ethical responsibility, and intellectual integrity offers a timely reminder of the values that should guide the path forward. His legacy challenges us to consider how science, technology, and humanism can work together to create a more just, compassionate, and enlightened world. In the end, Albert Einstein's life and work are not confined to the pages of history. His theories continue to shape our understanding of the universe. His moral philosophy continues to inspire acts of courage and compassion, and his example continues to call upon us to ask the fundamental questions about existence, justice, and the human condition. Albert Einstein's enduring legacy is a reminder that the pursuit of knowledge, when coupled with a sense of moral responsibility, can transcend time and space, offering hope for future generations in the face of an ever-evolving world.